We are very happy to make this presentation for what is for us an iconic pipeline, the first iron pipeline to be provided with polyethylene encasement and the control of corrosion. Installed by the Lafourche Parish Water District No. 1 in 1958. This 4-inch pipeline has been exhumed numerous times over 4 decades. It has never suffered a failure. And all of the many times we've inspected this pipe, we have yet to find evidence of significant corrosion. Today, we will provide the details of the latest investigation conducted in 2018 after 60 years of service. My name is Gregg, and I'm in charge of technical resources for the Ductile Iron Pipe Research Association. This paper, a part of the 2019 proceedings for this conference, was co-authored by Dirk Barrios, who was the general manager of the LPWD No. 1 at the time. We were both on hand in Nashville last year when the power went out. Dirk is now enjoying his retirement, but has left me to carry on with the presentation today. Lafourche Parish is located some 45 minutes to an hour southwest of New Orleans in the southern Louisiana Bayou country. The area has very aggressive soils, which is the reason in 1958 that the Water District was interested in working with the iron pipe industry to investigate this idea of corrosion control using polyethylene film as an encasement to protect the pipe from the aggressive environment that is not uncommon in this region. Here you can see the 2 locations where the crews of the Water District exposed the pipe for us. You can see the nearby canal and can perhaps get a feel for the low-lying nature of the area. We've been examining this pipeline for more than 40 years now, investigating its status every 5 years with typically encouraging results. Here are the soil characteristics from the soil taken from the 2018 investigation. This is a very low resistivity that is definitive of a very aggressive environment. It is enhanced by also exhibiting a neutral pH, the presence of sulfides, and a negative redox, which are indicative of the activity of anaerobic bacteria, which are considered to be depolarizers. A high concentration of chlorides was measured, also a depolarizer. The soil is saturated and influenced by a very high groundwater table. In fact, we were continually pumping water from the excavations to complete the examinations. The reference to the design decision model that we use to make recommendations for corrosion control will be discussed later, but this soil would find itself in the highest category for corrosion control recommendations in that model. Here we see the pipe having been exposed by the LPWD crew with the polyethylene still on the pipe but cleaned with water to remove the soil. You can see a couple of nicks in the film which occurred during the excavation, but the film was otherwise undamaged. Paul Hansen, one of our regional directors, is removing the film from the pipe. You can see we've wrapped tape around both ends of the exposed pipe in order to facilitate the removal of the film and also to facilitate the replacement of the film after the investigation has been completed.
Yeah, go ahead.
Yes, we have cast iron, double iron, asbestos concrete, C900, C160, C200,
C160.
As you can see, the film was installed as a sheet and it was very tightly wrapped, adhering somewhat to the pipe as Paul removed it. Here is the exposed pipe with the film removed. You can see the oxidation that is very visible. At this point, we will clean the pipe with a wire brush and water to determine the extent to which the corrosion has affected the pipe. You can also see the standing water in the bottom of the excavation, which required periodic pumping to allow us to conduct our examinations. Now the pipe has been thoroughly cleaned, which reveals that the oxidation that we saw was, in fact, superficial. After cleaning the pipe, we sound it using a geologist's pick or a welding hammer to see if there is evidence of graphitization which would indicate corrosion pitting that would be penetrating into the pipe wall. In both excavations and all prior excavations we've conducted on this iconic pipeline, the corrosion has proven to be only superficial surface oxidation. Before backfilling, we always wrap the pipe in polyethylene, in this case using V-Bio enhanced polyethylene, which I will discuss. We also send the film to a lab for physical testing. This installation in 1958 preceded the first AWWA standard for polyethylene encasement, which was issued in 1972. This film is pure low-density polyethylene and is an excellent quality film. You can see the results for thickness, tensile strength, and elongation in both the transverse and longitudinal directions. You can also see how they compare to the 1972 standard AWWA C105, which was favorable. In today's standard, the polyethylene is required to be a minimum of 8 mils thick rather than the 7.2 mils shown for the 1972 standard. The current standard also calls for linear low-density polyethylene, which is significantly stronger than the low-density film found in the first several revisions of the standard and the film used to encase the Lafourche Parish pipe in 1958. The standard calls for no regrind in the manufacture of the film and provides useful guidance on proper ways to install polyethylene encasement, including methods for use in wet trench conditions and guidance on properly installing service taps on polyethylene encased pipe. We also have videos on our website that show DIPRA's recommended methods for pipe fittings and tapping. Today, we recommend using an enhanced polyethylene film, V-Bio enhanced polyethylene, taking advantage of co-extrusion technologies in the manufacture of polyethylene film. We are able to introduce a corrosion inhibitor and an antimicrobial component that are infused in the innermost 1.5 mils of the film. The corrosion inhibitor will react to the development of a corrosion cell by sending molecules that attach themselves to the cathode and anode of an impending corrosion cell with molecules that build several layers deep. The bond is akin to a magnetic bond rather than an adhesive or chemical bond, so proper installation practice is required to take full advantage of this additive. In addition, the antimicrobial component will ward off the activities of the anaerobic bacteria that act as depolarizers that would otherwise allow the initial corrosion rate to continue unabated. Here we see the plots of data from one of our member companies' tests on traditional polyethylene film, such as the film found in Lafourche Parish. At the beginning, corrosion rates were registered that were very high, but diminished over time to very low rates. This would account for the superficial oxidation that we saw earlier, but over time the readings became very low to the point that the corrosion rates were measured at 0.7 mils per year. NACE considers corrosion to be under control when the corrosion rates are 1 mil per year or less. Here is a similar plot of readings, in this case 15 years of readings of corrosion probes under V-Bio enhanced polyethylene. As you can see, from day one, no discernible corrosion rates were measured, which has continued to be the result to this day. The design decision model is a risk-based model developed in cooperation with Corpro companies, one of the world's largest corrosion consultants. Based on statistical analyses of more than 60,000 data entries regarding the corrosion of iron pipe, it was originally introduced in 2005. It has recently been revised and made available to the public. We also have plans to attach it to AWWA C105 in its next revision as an appendix to that standard. The model balances the likelihood of corrosion against its consequences and provides a recommendation for corrosion control. The recommendations range from relying on ductile's inherent corrosion resistance in zone 1 to the use of V-Bio enhanced polyethylene encasement in zone 2 to the use of a metallized zinc coating and V-Bio enhanced polyethylene for distribution piping systems in Zone 5. All of these recommendations have a benchmark goal of providing a minimum average service life of 100 years. We know with assurance that the film was installed properly in Lafourche Parish in 1958. Over the years, we've had the opportunity to investigate hundreds of similar installations and have found that the primary problems with the use of polyethylene encasement are related to damaging the film during tapping operations, failure of the contractor to overlap the film at the joint during installation, and failure to ensure a snug fit of the film to the pipe barrel along its entire length. But as shown in Lafourche Parish, these are not insurmountable problems. With the current emphasis on proper asset management, it is so very important that steps are taken to ensure that any pipeline be installed the way it was designed to be installed. If those steps aren't taken, the best designs can go unrealized. What we have seen in the 60-year-old iron pipeline in Lafourche Parish is that proper installation had resulted in excellent corrosion control. The Lafourche Parish pipeline tells us what is possible and encourages us to make the effort. We sincerely appreciate the ongoing cooperative relationships that we've enjoyed with the Lafourche Parish Water District Number 1 and all of the relationships we've developed over the decades with water and wastewater utilities and their consulting engineers, including the investigation of another iconic pipeline, the first to be provided with cement mortar lining installed in 1922 in Charleston, South Carolina. In that study, Charleston Water System helped us conduct flow tests that confirmed the longevity of cement mortar linings. There's a video of this investigation available on our website, and a paper will be presented next year in Corrosion 21. It is this interaction and exchange of information that allows us to continue to improve the service that ductile iron pipe offers to our industry's customers. Thank you for your attention, and please feel free to visit us at www.dipra.org to see the many resources available for those who use ductile iron pipe, and to ask us any questions you may have regarding the application of ductile iron pipe.